Today we're looking at rules of exponents. So your essential question is, how do I simplify using the rules for exponents? Learning intention. I'm learning how to apply the rules for exponents. So you've got two warm-up questions. You've got two systems of equations. Pause the video and see if you can do those on your own. If you can, then you know you're understanding concepts. So pause the video now and do the warm-up questions. Well, I hope you tried. So if you're looking at this, you have to do some thinking. I've got 8 and I've got negative 6. I've got positive 14 and I've got negative 7. If I want to eliminate my x values, I'll have to scale both of the equations, not just one. However, if I want to eliminate my y values, all I have to do is to multiply the second equation by 2, and then I have positive 14y and negative 14y. They will eliminate each other. So the first equation doesn't change. 8x plus 14y equals 4. The second one, 2 times negative 6x is negative 12x minus 14y is equal to negative 20. Okay, so as I'm looking at this and thinking, my y values are gone. I've eliminated them. 8 plus negative 12, they're opposite symbols, so I subtract. 12 minus 8 is 4. However, 12 is the bigger number, so it's a negative 4x is equal to 4 plus negative 20. Once again, find their difference. 20 minus 4 is 16. Keep the negative symbol. I am now ready to divide both sides by negative 4, and x will be equal to 4. Okay, I know what x is, but now I've got to find y. Do I want to use the first equation or do I want to use the second equation? Really doesn't matter. So, looking at that first equation, 8x plus 14 times 4 is equal to 4. Okay, 8x doesn't change. Plus 14 times 4, it's 40 plus 16, which gives you 56, is equal to 4. Now I can solve. Oh, I put it in the wrong spot, didn't I? This is x is equal to 4, not y. That's even easier because I know what 4 times 8 is. So, 8 times 4 plus 14y is equal to 4. 32 plus 14y is equal to 4. Subtract 32 from both sides. $14y is equal to negative 28. Divide by 14. And y is equal to negative 2. What is your solution? Your solution is a point 4, negative 2. Okay, if you were still struggling, maybe you can do the next one on your own. Let's talk it out first, though. I've got a 5 and a 3. If I want to, one of them has to be multiplied by 3, and the other one has to be multiplied by 5 to create opposites. 4 and a 6. I could multiply the top one by 3 and the bottom one by -2 to create my opposites. Would you rather multiply by 3 and 2 or by 5 and 3? Truly doesn't matter. So let's multiply the top one by 3 and then the bottom one, well, let's make it a -3 because I've got to create opposites too. Top one by -3 and then the bottom one by 5. -3 times 5x is -15x. -3 times +4 is -12 y. And -3 times -14 is positive, because negative times negative is a positive. It'll be 30 plus 12, which would be 42. I've scaled the first one. Now I'm going to multiply by 5. 5 times 3 is 15, so that's 15x. 5 times 6y is 30y, is equal to 30. Okay, draw the line straight down. It's gone. Your x values have been eliminated. 30 minus 12 is 18. 18y is equal to 72. Divide by 18. (72) divided by 18 is 4. So y is equal to 4. Okay, now I still have to find x. So first one or second one doesn't matter. I think I'll choose the second one because I've got 6, which is positive, instead of the -14. So 3x plus 6 times 4 is equal to 6. 3x plus 24 is equal to 6. I am now able to simplify. I'll subtract 24 from both sides. 3x is equal to -24 plus 6, find their difference. 18, make it a negative because 24 is bigger. Divide both sides by 3. And x is equal to -6. So what is my solution? My solution is a point -6, 4. So I hope that that wasn't too awfully difficult for you to do. We still need to practice more on solving systems. So let's look at what happens when we are multiplying with exponents. If you have the same base, what happens? So it says to write this equation in expanded form and then simplify. Expanded form means that I stretch it out. So if I'm looking at x squared is x times x. If I'm looking at x to the 4th, x times x times x times x. 1, 2, 3, 4. Then bring another x down. And then x to the 6th is x times x times x times x times x times x. That is how many x's you are multiplying together. Remember, your exponent is made up of the base raised to the exponent. The base raised to the exponent. The exponent tells us how many factors of the base we have. So let's do a little bit of counting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 x's. So this is equal to x to the 13th power. This is what it looks like. So if we're looking at it as a rule, for all a, m, and n, which are elements of our real numbers, a to the m times a to the n is equal to a to the m plus n power. You're going to add those exponents. 2 plus 4 is 6, plus 1 more is 7, plus 6 more is 13. So that does work. In other words, you add the exponents when you are multiplying, you have the same base. So we're not going to expand anymore because we showed you what it looks like. We're going to use our rule. If I'm looking at the first one, a is my base, and I've got 3 plus, if it's not there, it's that imaginary 1, 3 plus 1 plus 4 plus 6. The a doesn't change. 3 plus 1 is 4, plus 4 is 8, plus 6 is 14. Any questions? Okay, for the next one, when you're working with exponents, you always put the numbers out front. So this is 2 times 3 to the second power. Then we're going to look at our exponents for x. X to the 5 plus. Remember, if it's not there, it's that imaginary 1 plus negative 3. Three squared is 9. So this is 2 times 9, x to the 5 plus 1 is 6, plus negative 3 is 3, x to the third power, which gives me 18x to the third. Okay, pause the video and see if you can do the last one on your own. What does it look like when we're multiplying and have exponents? I hope you tried on your own. So if we're looking at it, this is 2 to the 3 plus 4 power. We'll need to put g first because g is before h. G to the 1 plus 5 power. And then h to the 2 plus 1 power. So I've got 2 to the 7th power, g to the 6th power, and h to the 3rd power. Am I done? Yes and no. If they want it in exponential form, we're done. If they want you to find what number is equal to 2 to the 7th power, we are not done. So if I'm looking at 2 raised to the 7th power, I'm going to put it in my calculator. This little caret button right here is what we use to raise to powers greater than 3. So I'll hit the upside down V. I hit 7, I hit enter, and it's 128. So this is 128 g to the 6th power, h to the 3rd power. And I have simplified it. So that is the first rule. When you are multiplying, you add the exponents if the bases are the same. So now what comes next? Oh, we're going to divide. If we multiply if we add when we multiply, what's going to happen when we divide? If we add when we multiply, what will happen when we divide? You're right, we should subtract because they're opposites too. For all a, m, and n, which are elements of the real numbers, a to the m divided by a to the n is equal to a to the m minus n. In other words, you subtract. The exponents when you are dividing and have the same base. So let's take a minute and look. Let's go ahead and expand 2 to the 10th power out. There are 10 factors of 2. Now, 8 factors of 2. So if you're looking at it, this is what happens. 2 divided by 2 is 1. 2 divided by 2 is 1. And so forth. I am left with 2 times 2. So this is 2 squared, 2 to the 2nd power, which is equal to 4. Now, I've showed you in expanded form why it works. But what happens if you have numbers? If you have numbers, then you bring them out to the front and you'll have 4 divided by 12, x to the 12 minus 5 power. 4 divided by 12 is 1/3. X to the 12 minus 5 is x to the 7th, and we are done. Okay, now we're going to look at raising a base to a power. We've added, we've subtracted. What comes next? Multiplying is correct. So if we're looking at the rule, for all a, m, and n, which are elements of the real system, or real numbers, a to the m raised to the n is a to the mn power. In other words, you multiply. The exponents when you are raising to a power. So let's look at the next one. This is 2 raised to negative 2 raised to the 2 times 5 power, which is negative 2 to the 10th power. And that would be exponential form. Okay, now let's think a little harder. If I am raising a negative number to an even amount of powers, what will that number be, positive or negative? Well, it'll be positive, because with each pair, you have a positive number. Negative times negative, positive. Negative times negative, positive. You do that 5 times, and this will be a positive number. So this is equal to 1,024. Now I want you to look at what I put in the calculator. I knew it would be even, so I did not put the negative. If I put negative 2 raised to the 10th power, it will give me a negative number. But that is not correct. Why does it do this? Because it takes your exponent and then it multiplies the answer by negative 1. If you want it to do it correctly, you've got to put that negative 2 into parentheses. Now I've got the positive number I was expecting. What about 3? Oh, I've got 2 numbers in here. What's going to happen? Well, it becomes 3 to the 1 times 3, x to the 4 times 3, 3 to the 3rd, x to the 12th. I'm almost done. That would be, if they want it in exponential form, that is it. However, if they want it as a number, 3 times 3 is 9, times 3 again is 27. So this is equal to 27x to the 12th power. Okay, for all a and n, which are elements of the real numbers, a to the negative n gives you 1 over a to the n. 1 over a to the negative n gives you a to the n power. In other words, you cannot have a negative exponent. But if you do have it, it will flip it over that fraction bar. So 5 to the negative 3 power is 1 over 5 to the 3rd power, which is 1 over 5 times 5 is 25. 25 times 5 is 125. 1 over 6 to the negative 2 power is 6 to the 2 power. 6 squared, which is 36. For the last one, what's happening? The x to the negative 3, that means it becomes x to the 3rd here. Z to the 3rd stays on top. Okay. A to the 5th stays on the bottom. Y to the negative 9 comes up above. Or, negative 9. And we are done. Okay, let's see what happens. How do we solve? Well, if I'm trying to solve, the first thing I will do is to get the x squared by itself. I will divide by 2. X squared is equal to 100. The opposite of squaring is square rooting. So x is equal to The square root of 100 is 10, and that would be a positive or negative 10. You've got two square roots. You always have that, the positive, which is our primary, and then you also have the negative, which is our secondary. Okay, let's look at the next one. These are both going to flip to the other side of your fraction bar. 4 squared comes up here, 2 squared is down here. I can now simplify. 4 squared is 16 divided by 2 squared is 4. 16 divided by 4 is 4, and we are done. So, how do you know you're successful? You know you're successful when you can apply the rules of exponents to simplify expressions or to solve problems. So the first thing we looked at is x to the n times x to the m will give me x to the n plus m. X to the n over x to the m is equal to x to the n minus m. So that's the adding and subtracting part. So if I've got x to the n raised to the m, I've got x to the n times m. And finally, your negative exponents will flip it. And whoops, I did it the wrong way. I should have put 1 on top, and I didn't. We'll get that corrected here really quick, and we will be done. So, x to the negative n is equal to 1 over x to the n. Those are your rules in a nutshell. Hopefully you can apply them to simplify our exponents.